Hello scholars, welcome to Fun Scholar. So today we are going to discuss the topic cube and cube roots. This topic is meant to be for class 8 C.B.S.E students, but ICSE students can also enjoy the lecture. It will be beneficial for you guys too. Okay, so let's start. So the first thing what we get from the word cubes is this, something here and 3 is in the power means cube. Okay, and maybe you guys all have wondering that we already know that cube looks like this, right? Yes, in geometry cube means something which has all the vertices and all the sides as plane and all the vertices or all the sides are equal. Okay, but in cube, in normal arithmetic or algebra means something which has 3 in the power. Okay, and talking about cube roots, if we this will be the example of how does the cube roots looks like. Okay, like something we have to write in this root and then so talking about cube roots, that's something we have to write in this position and 3 would be the power in the roots. Okay. So this is called the chapter named cubes and cube roots. Okay, let's go further. So things we are going to learn in this chapter, that why do we need cubes and cube roots in our daily life, obviously, and there are introduction. There will be introduction. We will going to learn about what are the perfect cubes and cube roots, and examples and practice, and why did we learn. In the last we will going to do a recap. Okay, so going on, need in daily life, let's begin. So volume of 3D objects. Okay, so to check volume of any 3D objects we need cube and cube roots, right? So imagine you are buying a cube shaped box for storing your belongings. If you know the length of one side of the box, you can use the cube to calculate its total volume. As we know, volume means length into breadth into height. So from this formula we will going to actual value, we will going to learn the actual value of any 3D object or any kind of box. Okay, if the side of the box is 4 centimeter, the volume will be 4 into 4 into 4, that is 64. So or we can just write it like this, so it will be 64 in number. Okay, why it's useful? It helps in estimating how much space you need for how much materials is required to fill the box. For instance, if you want to pack a cube shaped gift, knowing the volume helps you pick the right size to wrapping paper or storage, obviously. So if this is a box and we have to wrap up the whole box with any wrapper or any paper, then we need the volume of this box. And how can you find the volume? You just have to find the length of this one, and you can, okay, this one is like a cuboid, because this length and this length won't be similar. But if you are consider a natural cube, a cube has all the sides equal, so it will be much more easier to find the volume of a cube, or else you also can find the volume of this cuboid just by measuring all the sides. Okay, so let's go further. Okay, construction and architecture. Obviously in construction and architecture we really need cube and cube roots, just like when constructing a building, especially for foundations or storage areas like tanks, the volume calculation of materials like cement or concrete uses cubes. Okay, let me give you a actual example. Just like when we are building a house, if this house is being built, just think this as the house. So you have seen that there are so many pillars in the houses people build, and then we build the whole house. So pillars are the foundation of any house. And talking about pillar, the pillar are generally in the shape of like a long cylinder, okay, or maybe if you round it, it will be cylinder. If you don't round it, then it will be a straight cuboid, right? Okay, so for those we have to find out that how much cement we have to put in to make it a solid shape. Okay, to find this kind of solution we need cube and cube roots, right? So next, for example, to find out how much concrete is needed, just I have been telling you about, for a 3 meter cubic tank you use the cube formula, that is volume, that is the height of that cubic tank, and we have to cube it, or we have to find the cube of that number so that we can find the actual value. Okay, why it's useful? The cube is essential for estimating material quantities and ensuring proper allocation, right? Okay, again, scaling objects. If you are designing a scale model of a house, the volume of your model would be proportional to the cube of the scaling factor. So if the house is scaled down by a factor of 1 by 10, its volume would be reduced by a factor of 10 to the power 3, that means 1000. So basically that if this is a bigger house and I am making a smaller version of it, so I have to measure carefully that how can this house can be transformed to this house, or how can I perfectly model out a smaller house by looking a bigger house. So for those kind of things we generally need cube and cube roots to find the actual value of the smaller models. Okay, and cube scaling helps the designers and architects to create proportional models and understand how changes in size affect total space. Obviously, if we are making a smaller model by looking a bigger model, we need the proportional value of those models. Okay, so we need it. Next, cube root in agriculture. Examples: farmers may need to determine how much space a certain volume of a soil will occupy in a cubic form. If you know the volume of a soil pile, you can use the cube root to find the side length of a cubic space with that same volume. For instances, if you have 125 cubic meters of soil, the cube root of 125 will be 5 meter. So basically that generally when we are considering volumes, that means that if this one is a packet, okay, so how much soil or how much anything will be filled in this can be calculated by finding out the volume. Okay, and to find out the volume we generally need cube or cube roots. Okay, so for agriculture, a bag or a kind of sack, if you want to put anything into that, you have to find the volume of that bag, that how much thing or how much like anything will be poured into that bag to fill the bag. And to find out those values, we have to find the cube or the cubic centimeter of that object. Okay, right? So okay, so now we are going on to the real examples or real cube and cube roots things. So if I if you have to do these kinds of sum easily, you have to memorize from up to 1 to 20 the cubes of the numbers. So talking about how they are happening, so 1 into 1 into 1 is 1, 2 into 2 into 2 is 8, and the similar way they all are calculating this. Okay, if you don't want to memorize all the numbers, you can just up to 10 you can easily, but from 11 to 20 you don't have to remember the all numbers. Just try to remember that 11 comes very often, so 11 would be beneficial. 15 comes very often, 20 obviously come, and maybe 12 and 13. Okay, so these all the numbers that which we are going to discuss it more and more, and this number comes more oftenly. Okay, but from 1 to 2 it would be beneficial that if you memorize all the cube of these numbers. Okay, let's go further now. So first of all, here is a video, and I am going to play the video. And you guys already know that I generally don't play so many videos. The videos will be in the LMS, and you guys can easily watch this in peacefully at your home. But let's play the first video. So
in the previous video, we have seen what are perfect cubes. Now let's see if there's any relationship between perfect cubes and odd numbers. Here we have the cubes of numbers from 1 to 5. 1 cube is 1 itself. 2 cube is 8. We can express this 8 as the sum of odd numbers 3 and 5. 3 cube is 27, and it can also be represented as the sum of odd numbers 7, 9 and 11. Similarly, we can represent the remaining cubes as the sum of odd numbers. Now, is there any pattern here? Yes, the first cube number is 1, which is the first odd number. The second cube number 8 is the sum of the next two consecutive odd numbers 3 and 5. The third cube number is 27, the sum of the next three consecutive odd numbers 7, 9 and 11. And this goes on. So in this way, we can represent perfect cubes as the sum of consecutive odd numbers. Now, consider the difference between cubes of two consecutive natural numbers. For example, 2 cube minus 1 cube. We get the difference as 7. Now, we can express the 7 as 1 plus 2 into 1 into 3. Why should we represent 7 in such a manner? Let's understand this. Observe that by writing it in this fashion, we can form a pattern here. 2 cube minus 1 cube can be represented as 1 plus the first number, which is 2, multiplied by the second number 1, multiplied by 3. Similarly, we can represent the difference between the cubes of the next two consecutive natural numbers as shown. So in general, for two consecutive natural numbers n and n plus 1, we have n plus 1 the whole cube minus n cube equal to 1 plus n plus 1 into n into 3. Now by applying the same pattern, can you find 51 cube minus 50 cube? Do share your answers with us in the comment section below. We hope that you enjoyed this video. To learn more about cubes and other interesting concepts, do visit our website.
So this one was a quick video that how perfect cubes can be found. That is, we can found the perfect cube of any natural number starting from 1. Okay, but all the other numbers, like 1 is a perfect cube because 1 has a cube root. Okay, just like 8 is a perfect cube because 8 also has a cube root, that is 2. Okay, but not all the numbers can be a perfect cube because they don't have a cube root, like for 3, 5, 9. Okay, so going further, we can find a pattern of this. We will going to discuss it about in the next slides. Okay, let's go further. Okay, what is the cube of a number? We have already seen the video and I have already explained it, so I am not going to play this video right now. And smallest multiple, that is a perfect cube, the answer will be 1 because 1 is the smallest multiple and also a perfect cube. So the two videos topic I have been explained. Okay, so let's go further. Like for any number, m into m is called the cube of m or m cube. Okay, and it's being written like this form, m to the power cube. So cube, or we will read this as cube of m, and m cube, m raised to the power of 3. Okay, so if you have to find out that how cubes are being found, so cube of m will be 5 to the power cube and it will be written as 5 into 5 into 5. Cube of 8 will be 8 into 8 into 8. Cube of 4 will be, sorry, it has -4, and cube of -4 will be -4 into -4 into -4. Be careful for this kind of sum. Like if I do this one, okay, so I have to find out the cube of -5. So I have written -5 into -5 into -5. Why I have used the brackets? Because if I don't use the bracket, 5 will have two symbols preceding by him. Okay, and we generally don't write two symbols repeatedly, like for any numbers preceding point or in succession point. Okay, so if we multiply this, we will just multiply 5 into 5 into 5 in normal way. So it will be, the answer will be 125, and if we multiply minus into minus into minus, the answer will be minus. Okay, minus minus plus plus minus minus, so minus. But if you want to do it in a single line, you can just take minus as the common, just like by the distributing property or applying distributing property, and you can write minus 5 into 5 into 5. Okay, so the answer will be minus 125. Right, done. And another special note is cube of a positive number is positive and cube of a negative number is negative, obviously. So what we have learned from the square, that any number, whether it is being positive or negative, square of any number becomes positive, right? But for in the case of cube of a positive number is positive and cube of a negative number will always be negative. Okay, remember this, right? So done. So let's go to the next one. Okay, product launch timeline. Okay, product means multiplication. Identify the problem, solve it step by step, separate it and get your answer. Okay, so they are talking about the perfect cubes. Let's see. The cube of a number is called perfect cube, obviously we have already learned it about. And for example, 6 cube will be 216, which is a perfect cube, and 15 cube will be 3375, which is also a perfect cube. Okay, conversely, given number of a perfect cube, if it can be expressed as the product of triplet of equal factors. Okay, so they just explain that how can we find the perfect cube or cube of any number. Okay, so they have found it out for 216. Let's do it for another number, like if I want to, let's go with a smaller number, 27. So 3 9s are 27 and 3 3s are 9. So we don't need another. So 27 can be written as 3 into 3 into 3, and if we try to find the cube root of 27, we can just write 3 into 3 into 3 and take a cube root symbol, and 3 into 3 into 3 can be written as just only 3. Okay, right? Then, so they have just find out that number for 216, which can be written like 2 into 2 into 2, 3 into 3 into 3, and then they have just we can just take 3 2s, 1 2 from 3 2s and 1 3 from 3 3s, and what they have done, they have just made it like 6. You don't have to if you want to. So 6 will be the answer. Okay, so 6 will be the answer. Let's go further. Let's practice, and for practice you guys can do it in your home just like any other number. So I am giving you a number that is 729. Okay, you guys can try it at your home. Okay, so let's go further. Okay, next, smallest multiple, that is a perfect cube. We have already learned about it, that is 1. And is 297 a perfect cube? Is 2744 is a perfect cube? Let's find out. Maybe 297 is not a perfect cube. Okay, if you memorize up to 10, you can tell just by saying it that 297 is not a cube. Okay, so let's find out. So 297 may be a prime number. Okay, okay, 297 is a prime number, so it can be expressed as a cube. Okay, so this is not a perfect cube. And talking about this one, that is 2744, let's check, is this one a perfect cube or not? Tie it with 2. Yes, this is a perfect cube. So from this we got 2 into 2 into 2 and 7 into 7 into 7. Okay, in the last step, so many people you have asked me that in the last step, do we stop just in the last by writing 1 or take this as this one? Okay, it's up to your choice that if you want to end at 1, and if you don't want to, you can just write 7 as it is. Okay, so the cube root of this will be take 1 2 from 3 2s and take 1 7 from 3 7s, so it will be 14. So 14 will be the answer. So is this one a perfect cube? The answer will be yes, this one is a perfect cube. Okay. Yes. So this one is not a perfect cube and this one is a perfect cube. Okay. Let's go. What is the smallest number by which 3087 should be multiplied so that the product is a perfect cube? Okay. Check carefully for this type of sums. So if you want to solve this, just start factorizing it just by in the division method. Okay, so let's start it by 15 and 3. It will be divisible by 3. Again 3. Okay. Just like the previous one. Okay, so for this number 3087 we already got 3 into 3 into something into 7 into 7 into 7. This is the number we have got. And talking about why I have made a blank space, that here they have asked that what is the smallest number by which this one should be multiplied. Okay, so talking about this one, we will multiply 3 to make it a perfect cube. Why? Because it has only 3 is being less for this number. So if you multiply 3, so then 1 3 will come out from 3 3s and 1 7 will come out from 3 7s, and the answer will be 21. Okay, so if you multiply 3 with 3087, the answer will be this. Got it right? So, and this will be a perfect cube. Okay, so this is the type of sum we will looking forward to, and there will be similar kind of sums in our next slides. Okay, see this one. So only 3 was missing to make it a perfect cube. So if you multiply this with 3, it will be a perfect cube. Okay, next. Now again the similar kind of sum, that what is the least number by which 6750 should be divided so that the quotient is a perfect cube. So this is the similar kind of sum, but they have just told us to divide it. Okay, so let's start this. So in the last position we have a 0, so it will be divided by 5. Okay, so clearly it is visible that which number should we divide from to make it a perfect cube. So this one will be divided by 5 because of 0, this one is also because of 0, this one is also because of 0. This one I have divided it with 2 because this one is 4 is a even number and 54 is also even number, and 27 is the cube root of cube of 3. So that's why. So numbers we are getting, that is 5 into 5 into 5 and 3 into 3 into 3, and only 2 is the excess number we are getting it, and they have told us to divide it. So if I divide it with 2, then 2 and 2 will get cancelled out and the answer will be 6750 by 2. This one will be the final answer, and 3375 is a perfect cube, and from 6750 we have to divide 2 to make it a perfect cube, right? Yes, they have already done it. That is 2 must be divided out. Okay, what is the least number by? We already done that. So cubes of odd natural numbers are odd as all this. 1 cube is 1, 3 cube is 27, 5 cube is 125, and cubes of even natural numbers are also even. Done. A cube has a side length of 8 centimeter and other cube has a side length of 6 centimeter. How much more volume does the first cube have compared to the second? Okay. So, if I consider these two are the cubes, and one cube is 6 centimeter and another cube is 8 centimeter, and just I have told it before that volume of any cube is side cube of any side. The volume will be cube of any side. So for this one, cube of 8, and for this one it will be cube of 6, right? So they have asked us that how much more volume does the first cube have compared to the second. If you want to, then just subtract it from this one to this one. Okay. So if I have to find 64 into 8, 512 and 216 will be 6's cube. So 296 will be that, right? So this much. So semi cube, because all the volumes has a unit of semi centimeter cube. So this much 296 cubic centimeter much volume does the bigger cube has than the smaller cube. Okay, let's go further. Yes, they have just done it with the perfect way. The volume of a cube is given by V equals to x cube, where x is the side length. If the volume of the cube is 125 centimeter cube, then find the value of x. Okay, so they have told us V is equals to x cube, and again they have told us that x is the side. So the x cube meaning is 125. Okay, so if x cube means 125, then the value of x will be 125 cube root. So the value of x will be done this much. Okay, and semi, because semi is the unit of the volume of the side of the volume, so it will be the answer. The volume of yes, they have done it correctly. Two cubes have side lengths of 6 centimeter and 4 centimeter. Find the difference in their volumes. Okay, so this one is just like the previous one, cube of 6 minus cube of 4. So it will be 216 minus 64. it will be 152, and centimeter cube. Okay, so this will be the difference of difference between bigger cube and smaller cube. Next, yes, they have just did it with the just by writing something. Yes, obviously you don't forget to write something. These all are the story sum. You have to write something to get the full marks in any mathematical question. Okay, let's go to the next one. Now we will going to discuss about what are the cube roots actually is. So what is the cube root of a number? Let's watch a video.
The base actually equals 262
Okay, so from this video we have already we learned that what are the cube roots actually is, and how can we find out the cube roots not in a very laborious way, right? So let's go further. Okay, so the cube root of a given number is the number whose cube is the given number. If cube root of a number is number x is y, then cube of y is x. If cube root of x is equals to y, then y cube will be x. This is the actual explanation of this statement. Okay, just like if cube of 3 is 27, then cube root of 27 will be 3, right? Just like this one. And cube of 7 is 343, so the cube root of 343 will be 7, and so on. And in the same way, 125 can be written as like this, and 512 or 512 can be expressed as the cube root of 8, right? Again, how do we find the cube root of a number using the prime factorization method? Okay, I am not playing the video because you guys already may have known the video. So find the cube root of 728. So let's try to find this one. Okay, so 7 plus 2 is 9, and 9 plus 9 is 9, 18. So 7 plus 2 plus 9 will be 18. And 18 is divisible by 3. So it will be divisible by 3. Okay, you all have to just recognize another time all the divisibility rules starting from 2, 3, 5, 6, 5, 7, 9, etc. So let's do this with 3. Next, this one 243. It will be again divisible by 3. Yes. So what we have got, we got 3 into 3 into 3 into 3 into 3 into 3. So total 6 number of 3's. And if we write it again, so we will take 1 3 from 3 3's and again 1 3 from 3 3's. So it will be 9. And if you want to reverse verify it, 9 into 9 into 9 will be 81 into 9 and 972. So this is the way which we can find the cube root of. Okay, let's go further. Yes, they have already done this like the same process. Next, find the cube root of 1728. Try to do this one with me. Okay, so this has 8 in the last position, so this is an even number and all the even numbers can be divisible by 2, and we will start it with 2. You don't have to try it with the bigger numbers to lessening the time, just do it by the way you like it. So we are having okay, so we will write this again by taking 3 to 1 1 2 from 3 2 1 2 from 3 2 and 1 3 from 3 3. So 12 will be the answer. So 1728 is the cube of 12, or 12 is the cube root of 1728. Done. Yes, they have just did it like the right way. The next, find the smallest number by which 210125 must be multiplied so that the product is a perfect cube, just like the previous one. 210125. Okay. So let's start dividing it with 5 because it has 5 is in the last position. So it will be divisible by 5. Okay. So 5 4s are 20, 1 remainder, 0 comes, 5 2s are 10, then 1 comes, not divisible, taking 0, taking 2, 5 2s are 10 and 2, 5 25, 5 5s. Again do it with 5. 5 8s are 40, 2 is the remainder, 0 comes, makes it 20, 5 4s are 20, 2 comes, not divisible, taking 0, 5 comes, 5 5s are 20. Done. Again take 5. Done. 5 1s are 5, 3 comes, 4 comes down. So 5 6s are 30, 4 remainder, 0 comes, 5 8s are 40, then again 5 comes, 5 1s are 5. Okay. So in the last now 8 and 1 9, 9 and 6 15, 15 and 1 16. So it would be divisible by 3. So again 7 7 not 9 not 9 9 7 8 1. Okay, so just look at this one will be divisible by 41. Okay, this one is quite harder one to find out. Okay, you guys have to remember this kind of sum, okay, this kind of numbers if they comes out. So if you don't want to remember it, or you just the way you got forgot, so the thing you can do, so these are the 5 5 5, and the thing which you can do to remember this kind of, okay, this one is maybe a okay 27 80. What you have to do, you guys can, okay, this one is not divisible by 2, not by 3, not by 7, not by 5, not by 11. Okay, you have to try with different prime numbers. Okay, and to do this one, this will take time, right? And another thing, no, I'm sorry, but they don't have any another process to find out which number will be divisible, which number will can divide this one. Okay, so you have to remember this. So what we have got that find the smallest number by which must be multiplied so that the product is a perfect cube. So you have to multiply 41 to make it this a perfect cube. Okay. So maybe you have wondering that this is not a small number, but this is the smallest number which can be multiplied with this one to make it a perfect cube. Okay. So this one was a quite harder one, or maybe the calculative one. You have to remember this sum. Okay. And generally they just repeat this kind of sum in every test. So you don't have to worry about it very much, just practice it, and so all the sums will get remembered in your mind. Okay, next one. Okay, cube root of a negative perfect cube. Okay, we have already discussed it about that how we are getting minus m cube of any number. Okay, and like if you are asked to find the cube root of minus 216, you have to take minus out of the cube root and then you have to find the cube root of this number. Okay, so 216 and 6 minus 6 will be the answer, right? Next, yes, they have given the examples of minus 8, minus 1000 and all that. Okay. Again, for example, they have given the examples of how can you break down of any cube root just by like taking x, cube root of x and cube root of y can be written as like cube root of xy, and cube root of x and cube root of y, cube root of z can be written as cube root of xyz. Okay, just for example, they have given some examples of this, that how can you break down two numbers and find out their cubes. Okay. Yes, these all are the examples. Yes, they have already given you the examples that how can you solve these kind of sums. Okay. How do we find the cube root of a large number in few seconds? So let's watch the video.
Only these two things. Cubes of 27. So we take the number from the first column corresponding to it and write it in the units place of the answer. The number corresponding to 27 is 3. So we write 3 here. So the first step directly gave us the units digit of the answer. Remember, the answer is the cube root of 2197. The next step is interesting. We ignore 3 digits from the right of the number. So we ignore 197 for the moment and look at the number that remains. It's 2. This number is very crucial. We check where 2 is placed in the cubes column. That is, we check the position of the remaining numbers in the cubes column. In the cubes column, the number 2 lies between 1 and 8, between these two numbers. That means it is placed between 1 cube and 2 cube. We basically look at the corresponding number column. The last step is very important. Now that we know where it is placed, we choose the lower number in the corresponding number column. The lower of 1 and 2 is 1. That's it. This is your nth digit. So cube root of 2197 is 13. Remember, we always choose numbers from the first column, which is the numbers column, to write the digits of our answer. 3 was chosen from here and 1 was chosen from here. This looks really long at the first look, but with practice, trust me, you'll be able to solve it in 5 seconds. Now let's solve another problem so that you understand better. Say we want to find the cube root of 195112. This number is 6 digits long and hence its cube root will be 2 digits long. Remember, cube roots of large numbers which have 4, 5 or 6 digits will always be 2 digits long. Now let's see the units digit of the number. It's 2. In the cubes column, we look for a number which has its units digit 2. Yes, it's 512. And the corresponding number in the numbers column is 8. So we write a 8 in the units place of the answer. Now we ignore 3 digits from the right. That is 112. And what remains is 195. Now where is 195 placed in the cubes column of the table? It is placed between 125 and 216. That is, it is placed between 5 cubed and 6 cubed. So from the numbers column, we choose the lower number among 5 and 6. It is 5. And we write this number in the tens place of the answer. Hence, the cube root of 195,112 is 58. With good practice, you will be able to solve this in 5 seconds. And remember that this method is a shortcut and cannot be used to solve questions in your exams. You may use this method purely to verify your answers.
Okay, so there is we have learned a shortcut method that how can we verify the answers of any cube roots of a big number, like, and how they are doing it. What you have to do, you have to just remember this table, okay, and by seeing the unit digit of any number, you have to find out that where does the numbers lies. So for 7 is the unit digit of 27, which is the cube of 3. So we are writing 3 in it, and then we have to ignore the 3 digits from the right. Okay, so the position of the remaining number in the cubes column, which will be this one, and here it was, if we consider removing all the 3 numbers, we are getting 2, and 2 is the number between 1 to 8, which is the cube of 1 and 2, and we are writing 1 here, taking the lower number. Okay, and for this one we are also doing this in the same way, right? So this is the quick and short method that how can we find the cube root of any bigger number. Okay, and this is a shortcut route, but it doesn't have any like theoretical proof. Obviously this is for the practice. Humans have invented it, and again we will be, maybe we are going to apply this in so many kind of sums, but for us it won't be applied in any like story sums. Okay, right? So let's recap this, that what did we learn from this. So starting from it, that like why are we studying this chapter, what are the cube and cube roots are, and what is their application in our daily life. So these all are the application in the daily lives. Then we have to remember from, then we have studied that cube of numbers starting from 1 to 20, and it would be better that if we memorize this like from up to 20, and if you don't want to, then you can just remember it from up to 10. Then we have learned that what are the cubes actually is, and how can we solve the cube related problems. And then we have solved some problems. Again we have learned that what cube roots are. We have also solved some volume related questions. Then we have solved the cube root related questions and learned that what cube roots actually are. And there are similar questions that are connecting cube and cube roots. And then we have learned that how can we find the cube root, just like by the short method. Okay, so that's it for today, guys. I hope you have enjoyed the video here. Let's see in the next class. Okay, thank you guys. I'm signing off.